All right, people, you can see me now. Yay. All right. Now, last thing we were talking about is water, right? Now, water is the universal solvent. It's very, very good at dissolving things. Now, since we're talking about dissolving things, there's a little bit of nomenclature, a little bit of words you need to learn, some few things gotta get familiarized with. Now, if you don't remember, a homogeneous mixture is something that's evenly mixed throughout, right? Now, when that mixture is in solution, that means when it's dissolved, when it's dissolved, you call it a solution, right? An aqueous solution is a solution that's dissolved in water. Aqueous, so like if you know from the Latin word aqua, right, like water. Now the parts to a solution, the solute is whatever you have more of. Whatever's doing the dissolving is your solvent, and then your powder, like your, what is that thing that people who work out use? Pre-workout, creatine, whey protein, all those powders that you mix up, those are your solutes, because that's what gets dissolved in your water, in your milk, or whatever you put that stuff in. I wouldn't know. All right. Now, there are things that are dissolved, right? So there's three things that you really need to know. There's electrolytes, and there's non-electrolytes, and then there's two types of electrolytes. There's strong electrolytes, and there's weak electrolytes, and then there's the non-electrolytes. So I guess there's the three electrolytes thing. I was done goofed, whatever. But so a strong electrolyte is something that has a lot of positives and a lot of negatives present. And when there's a lot of positives and a lot of negatives present, if you test it using like a little light bulb, we'll do a little experiment with this. The light should shine bright. And a weak electrolyte, let's see, I think I have pictures of it. I do have pictures of it. Awesome. So a strong electrolyte will have a lot of positives and a lot of negatives dissolved in there. So if you had a little light bulb in there, it would have a bright light. Now, if you had a weak electrolyte, it could be very dilute, or maybe it's just not fully dissolved, and you'll have a few positives and a few negatives, and the light will be very, very dim. The light will be very, very dim, as you can see right here. Now, you have non-electrolytes. Non-electrolytes are things that dissolve, but they still don't produce any electricity because they don't have any positives or any negatives. An example of this is the substance ethanol. Ethanol is an alcohol. All right. And if you don't remember, I talked about how like methane has one carbon, ethane has two carbons, propane has three carbons, etc., etc. Now, you don't have to know that, but it just tells you the number of carbons, right? So right here, 2 carbons, ethanol. If it had 1 carbon, it would be methanol. If it had 3 carbons, it would be propanol. 8 carbons, octanol or whatever. All right. Now, main thing I want to show you was this right here has the same polar bond that water did, right? So it results in that same partial positive, partial negative. So because of that, partial positive, partial negative, water can come and dissolve it. But when water dissolves it, there is no positives and no negatives floating around like it did on the previous example. On the previous example, it separated the plus and it separated the negatives so that they're floating around. Now, in this scenario, it dissolves it, but there's no positives, no negatives floating around. So this is a non-electrolyte and it doesn't produce any light. This would happen with sugar as well. Sugar dissolves in water, but it doesn't produce any electricity because there's no positives and no negatives floating around. There's none. There's no positives, no negatives. Particles are still floating around, but they don't have a charge, or they don't have a partial charge. All right. Now, let's talk a little bit about some of the notation that's going to be used. So, a salt is any ionic compound. All right. And the way you show that ionic compounds are dissolved in water, well, let's take NaCl. If NaCl is going to be in water, let's say it's aqueous, right? Aqueous means dissolved in water. Well, when something is dissolved in water, when an ionic compound is dissolved in water, they're not together anymore. They're not a formula unit. Instead, they separate. They're their own particles. So you'll have an Na plus and you'll have a Cl minus. So right there, this is what's happening inside your solution. You have positives and you have negatives floating around. They are not stuck together anymore. They are not stuck together anymore. Okay? So just keep that in mind whenever you see an aqueous ionic compound. They're not stuck anymore. They're floating. They're floating. All right. Now, a strong acid. A strong acid is a strong electrolyte. Except it has the H+. Acids have H+. Right now, that's the definition we're going to use. It's called the Arrhenius definition. Later on, we're going to learn about other acids. But right now, the H+, so you think of HCl, think of it as an ionic compound. HCl is aqueous, so it breaks apart into its two components. It breaks apart into H+, and it breaks apart into Cl minus. So both of those things are floating around. Now, the more H pluses there are, the stronger your acid's going to be, the scarier it's going to be, okay? Now, the same thing with strong bases. Strong bases are just ionic compounds as well. Strong bases are just ionic compounds, except the main focus is the hydroxide, that OH minus. Since it's aqueous, what happens is Na plus breaks apart, and then we have OH minus. It is always important to note that the positives and the negatives, the charges should be equal on both sides. On the left side, no charge. On the right side, the positives and the negatives cancel out, so no charge as well. All right. Now, this is just how we write stuff out. Now, the weak electrolytes. These are all strong electrolytes. What does it mean to be strong? Strong means it fully dissolves. So there's a lot of particles floating around, a lot of positives, lots of negatives. That's why the light is bright. A weak electrolyte like this one will only have a few things dissolved in there. So here are the types of weak electrolytes. Slightly soluble salts. These are things that don't fully dissolve, but they dissolve a little. So let's say you have a solution, right? So you have a bunch of water and you add some barium fluoride. Fluoride, those of you that brush your teeth, I hope it's all of you, you got that fluoride in your toothpaste, right? Fluoride is kind of really, really bad when it's in ion form. Well, not really. Never mind. That's kind of bad information. Scratch that. Fluoride is really, really good at making solids, and it won't really break apart. So what ends up happening is that barium fluoride will kind of stay undissolved, but some of it will dissolve into it, right? Some of it will dissolve, or it'll dissolve really, really slowly. So this is going to be a weak electrolyte because it doesn't fully dissolve. It will still break apart. It will still break apart like this, but not entirely. There will be, so this one now there's two F's, right? So it breaks apart into two F's. So there will be some particles floating around. There will be some particles floating around, but not too many. Why is this wrong? Oh, that should be a +2. That's what was wrong. There should be a +2. But anyways, they're not floating as much, so they don't leave that charge. Now, some weak acids like vinegar, acetic acid, hydrofluoric acid, hydrocyanic acid, and then nitrous acid. Those acids are very weak. That means they don't fully dissolve. That means only some of it dissolves. So if you have vinegar, right? If you have vinegar, that means that a lot of it is going to stay as HC2H3O2, but part of it is going to break apart into H plus, and then the other part will break apart into C2H3O2. So it's still going to have those things floating around. That's why it's going to create some light, but it doesn't do it so well. All right, so if you're making a battery, you're not going to want to use vinegar as your acid. You're going to want to use a strong acid like sulfuric or nitric or what other ones, or hydrochloric. You want something dissolved in there. Now, weak bases, we're going to talk more about the different types of weak bases. You're going to have a little bit of trouble identifying them for now. But remember, NH3, weak base. Memorize that one. That's super important for the rest of the year. NH3, weak base. All right, so non-electrolytes, already talked about this. They dissolve, but they don't produce ions, or they don't produce. I said non-electrolytes dissolve, don't produce ions, like your alcohols, your sugars. Now, okay, that's kind of it. I just want to talk about those three things. That's kind of it. We're going to talk about how we measure concentration in solutions. And that's where the stoichiometry comes from, okay? That's where the math is going to come from. I'll see y'all then.